Hey guys, Mr. B here, and in this video we're going to be going through the chapter 4 review guide. So this chapter is on isotopes and a little bit of the history of the atom and where the structure of it came from. So we'll start with some matching here and some vocab. It says number 1, neutron. So we're going to match this up with the proper terminology. So the neutron is the particle that has no charge to it. So if we look at our choices, we would see that this one is E. Okay, so the neutron, I think here is E, a subatomic particle that has no net charge. Number 2, isotope. Isotopes are things that have the same number of protons but different numbers of neutrons. So for this one, it is going to be F, an atom of an element with a different number of neutrons. Number 3, the proton. This is the subatomic particle that has a positive charge to it. So I believe this one is going to be B. Number 4, atomic number. All right, so there's some vocab now that kind of is confusing because it sounds very similar. So you have atomic number, atomic mass, and mass number. Atomic number is the number of protons that you're going to find in an atom. So this one is going to be letter C. Oh, not mean to do that. Let's try this again. Letter C, there we go. Number 5, mass number. Mass number is the number of protons plus neutrons. This is the mass of the atom, which only comes from those two particles. So this one is going to be H, the sum of number of protons and neutrons. Number 6, the electron. This is the charged particle in the atom that has a negative charge to it. So this one is going to be letter D. Number 7, atomic mass. So this is the average mass of all of the isotopes that exist for an atom. So this one is going to be letter G, average mass of all isotopes. And then lastly, number 8, the nucleus is the central part of the atom that has protons and neutrons in it. So this is going to be letter A. All right, so those are all of our choices. Let's move on to the multiple choice. It says number 9, which of the following is not a part of Dalton's atomic theory? So Dalton had 4 parts primarily to his atomic theory. First part is that all matter and material is made out of these things called atoms. Number 2, atoms of an element are similar, but atoms of one element are different from atoms of another element. 3, atoms can physically mix together, or they can chemically combine in whole number ratios to make new materials or new compounds. And lastly, number 4, atoms cannot be changed from one element to another element in a chemical reaction. So for the first one, letter A, all elements are composed of atoms. That is part of Dalton's theory. Letter B, atoms of the same element are alike. That is part of Dalton's theory. Letter C, atoms are always in motion. Now this is true, but this is not part of Dalton's atomic theory. As for letter D, atoms that combine to do so in simple whole number ratios, that is part of his theory. So our choice here that would not be part of Dalton's theory is letter C. Number 10, the nucleus of an atom is, so in the nucleus we have protons and neutrons. Okay, so the nucleus is not negatively charged. So that eliminates choice A and choice B. So it's either choice C, positively charged and has a low density, or letter D, positively charged and has a high density. So the nucleus is very tightly packed together, which means its density is very high. So this is going to give us a choice of letter D for our answer. That is positively charged and highly dense. Number 11, Dalton theorized that atoms are indivisible and that all atoms of an element are identical. Scientists now know that. Dalton's theories are completely correct. No. Atoms are divisible, okay? So he said they were indivisible, meaning you can't break them apart. That's not true. We actually know that you can break atoms apart into smaller particles, so that's not true. Letter B, scientists now know that atoms of an element can have different numbers of protons. Not true either. If it is an atom of a particular element, then its number of protons are the same. That's what makes it that element, so that's not true either. Letter C, scientists now know that atoms are all divisible. That is true. We now know that atoms are divisible into protons, neutrons, and electrons, so that's maybe the answer. Otherwise, letter D, scientists now know that all atoms of an element are not identical, but they all have the same mass. That's not true. They don't have the same mass because we have isotopes. They have different number of masses. So our best answer here is going to be letter C. Atoms are all divisible, which we now know again is true because we can break them apart. All right, number 12. The number of neutrons in the nucleus of an atom can be calculated by A, adding together the numbers of electrons and protons. Nope. We don't add together electrons and protons to find neutrons. The number of neutrons can be found by subtracting the number of protons from the number of electrons. Nope. Number of protons and electrons will be the same in an atom as long as the atom is electrically neutral, so that's not it either. Number of neutrons in the nucleus can be calculated by subtracting the number of protons from the mass number. That is correct, right? So remember, the mass number is protons plus neutrons. So if you subtract the number of protons from the mass number, you're going to be left with just the number of neutrons. So this is going to be letter C for our choice. All right, number 13. The sum of the protons and neutrons in an atom equals, I should say atom, I think. There we go. The sum of the protons and neutrons in an atom equals the... So adding together the protons and neutrons is going to give us our mass numbers. This one is going to be letter D. This is basically very similar to the previous question we just answered. It's on the same concept. Number 14, all atoms of the same element have the same. So if it is the same element, then what makes that element the same is the fact that it is the same number of protons. Okay, so this one is going to be letter A for our proper choice. Number of neutrons can change between elements, even if it's the same element. Mass number is specific to isotopes. So, all right. Number 15, which of these statements is false? Electrons have a negative charge. That's true, so that one is not false. Letter B, electrons have a mass of 1 AMU. Nope, electrons are much, much smaller than that. Protons and neutrons both have a mass of 1 AMU, but electrons are smaller. So that's not true either, which means that letter B is probably our correct answer because that is false. But let's keep checking the other ones. Letter C, the nucleus of an atom is positively charged. That is true. Protons are found in the nucleus with neutrons. Neutrons don't have a charge, so the nucleus is positive. And letter D, the neutron is found in the nucleus of an atom. Also true. So the one statement here that is not correct, that is false, is letter B. Electrons have a mass of 1 AMU. That is false. All right, number 16. The atom of an element with atomic number 48 and mass number 120 contains... Okay, so atomic number 48 means we have 48 protons. If our number of protons is 48, that also means that our number of electrons is 48. So basically letter A is our only choice here because it's the only one that has 48 protons as the number of protons, which that's what the atomic number tells us. So I can already tell, I can already tell that this is going to be letter A. 48 protons, 40 electrons, and then 120 minus 48 gives us 72 neutrons. All right, number 17. How do the isotopes of hydrogen 2 and hydrogen 3 differ? Okay, so the number 2 and the number 3 is the mass number. So that tells us how many protons plus neutrons there are in hydrogen. Now, I'm going to pull up a periodic table here real quick, just so that way we can have one available, because we might need one. So let's go periodic table. Just pull up this one here. All right. So hydrogen is element number 1 on the periodic table. Okay, that means it has 1 proton. So if it's hydrogen, there's 1 proton no matter what. The 2 is the mass number, so that is protons plus neutrons, which means hydrogen 2, since it has 1 proton, that also means it has 1 neutron. That's how we get to 2, okay, hydrogen 2. Hydrogen 3 has 1 proton, but it has 2 neutrons, okay, that's how we get to 3. So the difference between the two is that hydrogen 3 is going to have 2 neutrons. Hydrogen 2 only has 1 neutron. So the best choice here is going to be letter B. Hydrogen 3 has 2 neutrons. Number 18, the number 80 in the name bromine 80 represents. So this is just like in the previous one. The number 80 is going to represent the mass number. That is how many protons plus neutrons there are. So that is going to be letter B. Number 19, which of these statements is not true? Atoms of the same element can have different masses. That is true. The nucleus of an atom has a positive charge. That is also true. Atoms of isotopes of an element have different numbers of protons. That is not true. Okay, so if it's the same element, they will have the same number of neutrons, or the same number of protons, so that is not a true statement. So this one is false. This is letter C. Atoms of isotopes of an element have different number of protons. Atoms of isotopes of an element have the same number of protons. All right, number 20. If E is the symbol for an element, which two of the following symbols represents isotopes of the same element? Okay, so this is isotope notation, okay? When we write isotope notation, there's three things we have. One is the element symbol. Okay, in this case, that is the capital E. The second thing we have is mass number. Mass number is the number up top. That is how massive the atom is, okay, which that number will change. However, the bottom number is the atomic number. That tells you how many protons there are. If it is the same element, that number has to be the same for all isotopes, which means that if we look at our four choices, number 1 has 12 protons, and number 2 and number 3 have different numbers of protons, which means that cannot be the same element. However, number 4 has also 12 protons. So the two that would represent the same element would be number 1 and number 4, because that 12 down at the bottom tells us how many protons we have, and those have to be the same if it's the same element. So our best answer here is going to be letter C, number 1 and number 4. I keep clicking off. Okay, let's do this properly here. There we go. All right. Last question here. So it says there are 5 naturally occurring isotopes of the same of the element zinc. The relative abundance and mass of each are as follows. So let's zoom in a little bit here. So the relative abundance and mass of each are as follows. So we have zinc, zinc 64. It's 48.89% abundant, and they're giving us the specific mass. So it's technically 63.929, not 64. Then we have zinc 66, zinc 67, zinc 68, zinc 70. It wants to calculate the average atomic mass of zinc. Okay, so to find average atomic mass, we are going to take the mass of the individual isotopes. We're going to multiply those masses by their percent abundance as a decimal, and then we're going to add them all together. Okay, so we're going to take 63.929 AMUs times 0.4889, okay, that's 48.89% as a decimal, equals, okay, so let's do this on our calculator here real quick. I'm just going to use my cell phone because it's quicker. So 63.929 times 0.4889. So this gives us 31, and I guess we'll round to 4 significant figures because the percentage they're giving us is 4 sig figs. So this is 39.2 or 31.25 AMU. The next one here, same thing. We are going to take our mass, which is 65.926 AMUs, and multiply that by 0.2781. That's that percentage. So let's go 65.926 times 0.2781. So this gives us 18.33 AMU. Next one. Okay, so basically we're just going to keep on doing this until we have got all of our numbers. And like I said, we're going to add them all together. So let's do this real quick. 0.411 equals, so again, 66.927 times 0.0411. So this is 2.75 AMU. The next one here is 67.925 AMU times 0.1857 equals 67.925 plus 0.1857, so 68.11 AMU, and then amusement park. Okay, and then the last one here, again, we have 69.925 AMU times 0.0062. Okay, so again, we need to make sure we do our percentages right. 0.62% as a decimal is 0.0062. Okay, so you need to, again, make sure that you put your decimal in the right place. Otherwise, it's going to be too large. So 69.925 times 0.0062, and we get 0.43. I guess we have four significant figures, so 0.4335 AMUs. All right, and then to get our final answer, we're going to add all of those together. So let's do that out. Okay, so we have, yeah, that's all of them. Okay, so we have 31.25 AMU plus 18.33 AMU plus 2.75 AMU plus, oh, I messed up somewhere, didn't I? 67.925 times 0.1857. My bad. This is not correct. 12.61 AMU. My bad. Okay, so let's add that one in. 12.61 AMU plus 0.4335 AMU equals. Okay, so let's do this out. So 31.25 plus 18.33 plus 2.75 plus 12.61 plus 0.4335 equals, and I get 65.37 AMU. That is the average atomic mass for zinc. All right, guys, that is the last question on the review guide. Hopefully that helped. But again, as always, if you have any other questions, feel free to email me or talk with me in class, or maybe we could do a Google Meet or something along those lines. Just make sure, again, you get your questions answered. All right, that's it for this one. I'm Mr. B. Thanks for watching. Good luck on your test. Bye.